Hi, welcome to video 2 on Turing machines and linear bounded automata. So let's just review the formal definition of a Turing machine is a 7-tuple. We have our states, we have our alphabet and our tape alphabet, our transition function, which includes a left or right, the initial state, a special symbol called a blank, which is only part of the tape alphabet and not part of our alphabet, and our final states. So let's take a look at this. We're getting a little more complicated with our Turing machines. So here we have our alphabet is AB. Our tape alphabet is AB with the special symbol, which is a blank. Our states, we have Q0, 1, 2, 3, 4, and 5. Q0, 1, 2, 3, 4, and 5. And we have our final state, or Q5. So the way that we are going to do these transitions, if you start in Q0 and the symbol is an A, you're going to move to Q1 and you're going to move right along the tape. So that would be the first A. Then we need to get the second A. So you go from Q1. So this is the first A is here. Then the second A is here. Then the third A is here. So you need to have 3 A's. Then once you get your 3 A's, this right here is for A star, because A star means you can have any number of A's. So a string that could be accepted would be 1, 2, 3 A's, and then you could hit the blank and go to accepting, right? So you can have just 3 A's. So one string is that's accepting is 1, 2, 3 A's. So you can follow along here. It's easy to follow along by looking at the this right here. This is A, A, A. Then once you get to Q3, if you get to Q3 and you encounter a blank, then you're going to go to Q5 and it will be accepting. If you have the string A, again, you would just go A, pick up one more A here, you could still be accepting. Now we also have the B's here. So this right here is for the B asterisk. So if you're not familiar with the Turing machine, I encourage you to watch video 1 before watching this. So, but what these transitions are, if there's an A on the tape, I leave the A on the tape and I move right. So this would represent the tape. A, B, B, blank, right? So we can go through our transitions and see if we're going to end up in an accepting state. So I have this is an A. I'm in Q0. This is an A. I leave it an A. I move right. Now I'm in Q1. It's an A. I leave it an A and I move right. Now I'm in Q2. Q2. This is an A. I leave it an A and I move right over to Q3. Now I'm in Q3. I've encountered a B. So I leave it a B and I go to Q4. Now I'm in Q4 and I have a B. I leave it a B and I stay in Q4. Now I'm in Q4 and I encountered a blank. So I'm going to move to Q5 and go back left here. And so now I have finished in an accepting state. So A, B, B is accepting in the language, and you can see it's accepting in the language by looking at the regular expression there, and also by following the transitions, by looking at the automata. And so hopefully this is pretty clear, because we're going to get into more complicated examples shortly. All right, so here is an example of a Turing machine, and the length of the string is odd, right? So an A or a B is fine, but you're going to wonder why I'm not leaving the string alone. It's because when you're counting, you probably, it's a good idea when you're counting to change the symbol that's on there so you don't accidentally read it again. So we're just, in this case, we're going to count the symbols and make sure that we have an odd number. So it's very obvious here. And I have another error here because this should not be Q5, this should be Q2. I'm going to have to fix that on the, sometimes I notice things when I'm doing a video. So our tape would be like this, A, B, A, right? So if you are here, you encounter an A, you can count that, change it to a blank or whatever you want. Move right, you have a B, you count that. Move right, you have an A, you count that. You move right. Now that we have reached our blank here, then we're going to move back left and go into the accepting state. And you can also look at this. This is 1, 2. This is 3, 4. This is 5. So any odd number of strings in our, any odd number of symbols in our string, and you will eventually hit the blank at the end and go to the accepting state. Oh, I have one here that we could have tested. So let's do that. All right, so we already did that, ABA. Here's one that's not accepting, so let's just try it here. I'm in Q0, change this to a blank and move to Q1. I'm in Q1, change this to a blank, go back to Q0. I'm in Q0, change this to a blank and go to Q1. Oops. I'm in Q1, change this to a blank and go to Q0. So if you take a look here, I do not have any transition defined, a transition from Q0 with a blank. It is not defined, so therefore it's just going to stop here in Q0. It's never going to make it to an accepting state, and therefore any string that has an even number of symbols is not going to be accepting or ever lead to the accepting state.